Why do the near side and far side of the moon look like two completely different worlds? The story starts 4.5 billion years ago. As the solar system was still forming, a Mars-sized world called Theia slammed into the early Earth. The debris from that collision spread into orbit and slowly clumped together into the moon. At 3,474 kilometers across, it's about a quarter the size of Earth. Only 4 other moons in the entire solar system are larger, and every single one of them orbits a gas giant. For a rocky planet like Earth, having a moon this big is not normal. Inside, the moon has a crust, a mantle, and a partially molten iron core. Billions of years ago, that interior was still churning with magma, and volcanoes erupted across the surface. But the crust on the near side is much thinner than on the far side. Magma broke through more easily, flooding huge regions with lava. Those dark patches we can see with the naked eye from Earth are these solidified lava plains. Ancient astronomers called them seas. On the far side, the crust is thicker. Magma never broke through. Instead, that surface is packed almost entirely with craters, billions of years of impacts with nothing to erase them. One moon, 2 completely different worlds. So why do we only ever see one face of the moon? Earth's gravity locked it in place. The pull on the near side of the moon is slightly stronger than on the far side, and over billions of years, that tiny difference created friction that slowed the moon's rotation until it matched its orbit exactly. Now it always shows us the same face. It wasn't until 1959 that the Soviet Luna 3 probe sent back the first images of the far side. And recently, the Artemis 2 mission captured the sharpest views yet, revealing just how stark the difference really is. Let's start at the far side South Pole, with the South Pole Aitken Basin, the largest impact crater on the moon, and one of the largest known impact craters in the entire solar system. It's over 2,500 kilometers across and 8 kilometers deep. One single impact carved out a hole covering almost the entire southern half of the far side. Billions of years ago, something hit this spot with so much force it gouged out an area roughly half the size of the United States. Near the northwest edge of that basin is something strange, lunar swirls. Pale, spiral-shaped markings spread across the surface, almost like someone dragged their fingers through the dust, and the marks just stayed, for billions of years. Scientists think weak local magnetic fields deflect solar wind here, keeping this ground lighter than its surroundings. Head northeast and you'll find the Tsiolkovsky crater, about 185 kilometers wide. The impact punched the ground down, and then the rock rebounded upward, forming a peak right at the center. It's a geological moment, frozen forever. Further north is Mare Moscoviense, a rare lava plain on the far side, 280 kilometers across. That impact thinned the crust enough for magma to break through, creating a dark patch that looks out of place on the far side. To the southeast sits the Hertzsprung Basin, 570 kilometers wide, formed 4 billion years ago. Near its edge is the much younger Vavilov crater, about 98 kilometers across. Its sharp, raised walls stand out clearly against the worn-down craters around it. Continue west and you reach Mare Orientale, the best-preserved large impact basin on the moon, and also one of the youngest. 3 concentric ridges form rings like a target, and the interior was never flooded with lava, so the impact structure remains intact. From Earth, we can only ever see its edge. The Artemis 2 crew were among the first humans to see its full shape during their flight. Right next to Orientale is the Grimaldi crater region, and it hides an invisible threat, a mass concentration. The impact pushed dense rock toward the surface, making gravity here slightly stronger than its surroundings. Early lunar orbiters flying over this area would have their orbits quietly tugged off course, as if they'd fallen into an invisible gravitational trap. The near side has its own dense story. In the south is Tycho crater, 85 kilometers wide, formed about 110 million years ago, geologically very young for the moon. The impact threw rock outward in bright rays that stretch for thousands of kilometers, visible to the naked eye during a full moon. It's the brightest feature on the lunar surface. Near the center of the near side is a feature that almost doesn't look natural, the straight wall. About 300 meters high and 110 kilometers long, it looks almost engineered. It's actually a fault scarp, a massive slab of rock that slid down along a crack as the moon cooled and its crust fractured. That crack extends 42 kilometers underground. The western near side holds the moon's largest dark plain, the Ocean of Storms, covering 4 million square kilometers, larger than all of Western Europe combined. It's the result of billions of years of continuous volcanic activity. In the northern part of this lava plain sits the Aristarchus crater, 40 kilometers across, one of the brightest geological features on the moon. But it has another reputation. For centuries, astronomers have recorded unexplained phenomena here. Brief flashes, hazy patches, sudden changes in brightness, phenomena that still don't have a confirmed explanation. Some scientists think it could be residual gas escaping from inside the moon, or unusual optical effects from dust. Next to the crater stretches Schroeder's Valley, the largest lava channel on the moon, winding for hundreds of kilometers. From above, it looks like a dried-up riverbed, except there was never water here, only flowing magma billions of years ago. Further southwest is the Marius Hills, a dense cluster of rounded domes. They're not impact craters, and they're not crustal folds. They're the result of thick magma slowly oozing out and solidifying. Within these hills is the Marius Hills Pit, a perfectly round opening that reflects no light in photographs because the ground here has simply collapsed. Billions of years ago, magma flowed underground while the surface cooled and formed a crust. When the magma drained away, it left an empty tunnel behind. Eventually, the crust above couldn't support its own weight and caved in, opening this pit straight down into a lava tube below. A similar pit exists near Mare Tranquillitatis, and beneath it may lie an entire network of underground caves. These caves could matter enormously for humanity's future. The lunar surface is hit constantly by radiation, extreme temperature swings, and micrometeorite impacts. Even the soil itself is dangerous. Lunar dust is fine as powder, but sharp as broken glass. Apollo astronauts' gloves were worn down to the point where their fingers nearly broke through. But inside these pits, the rock overhead provides shielding from radiation and impacts. NASA's calculations show that inside some of these pits, the temperature stays steady around 17 degrees Celsius, while the surface outside can drop to -171. Stepping inside means crossing a temperature difference of nearly 200 degrees. In the northwest of the near side lies Mare Imbrium, the most dangerous region for spacecraft orbiting the moon. It holds the strongest gravitational anomaly on the moon, and early satellites passing over it had their orbits visibly thrown off course. The western plain of Imbrium was the working ground of the Soviet Lunokhod 1 rover, which traveled over 10 kilometers and sent back huge amounts of surface imagery. It also left behind a laser reflector, and scientists on Earth still bounce lasers off it today to measure the Earth-Moon distance with extreme precision. That measurement revealed something remarkable. The Moon is drifting away from Earth by 3.8 centimeters every year. It has never stopped, and it never will. The formation of the Imbrium Basin shaped the Montes Alpes, the Moon's highest peak, about 3,600 meters tall, comparable to Mont Blanc on Earth. But here there's no snow, no air, and no life of any kind. Along the basin's edge is Sinus Iridum, once a complete crater, later flooded by lava from within, leaving only a semicircular ridge. From orbit, it looks like a natural amphitheater. The Montes Apenninus mountain range stretches about 600 kilometers, with some peaks rising 5 kilometers above the surrounding plains, close to the height of Denali, the tallest peak in North America. Apollo 15 landed at the foot of these mountains. Astronauts drove the first lunar rover in history to explore the Hadley Rill, bringing back basalt rock 3 billion years old. Before leaving, they placed a small aluminum sculpture called Fallen Astronaut, engraved with the names of 14 American and Soviet astronauts and cosmonauts who had died, the only monument humans have ever placed on another world. The seismometer Apollo 15 left behind recorded moonquakes. Earth's gravity tugging on the moon, combined with meteorite impacts and residual internal heat, makes the moon tremble from time to time, with quakes reaching magnitude 5.5 and lasting over 10 minutes. A world we've called dead for thousands of years has never actually been completely still. The Apollo 17 landing site, Taurus Littrow Valley, gave scientists another surprise. Astronauts dug into the surface and found orange soil, tiny beads of volcanic glass, formed when gas blasted molten rock into droplets billions of years ago, which cooled and solidified mid-flight. On the surrounding slopes, you can still see the tracks of boulders that rolled down after being shaken loose by moonquakes. With no wind and no rain, those tracks will remain visible for millions of years. The Apollo 17 rover is still parked there today, leaving behind landing gear, scientific instruments, and flags, all still exactly where they were left. Now scientists are focused on the lunar poles. At the North Pole, the sun sits almost on the horizon, and deep craters never receive direct light. The South Pole is even more extreme. Shackleton Crater has walls so steep that its floor has never been touched by direct sunlight for billions of years. Temperatures there drop to minus 230 degrees Celsius, making it one of the coldest places in the entire solar system. And hidden inside is something that shouldn't exist on the moon: water ice. Scientists estimate that the permanently shadowed craters at both poles could hold hundreds of millions, possibly billions, of tons of water ice, delivered by comets and micrometeorites billions of years ago, and never melted since. In 2009, NASA's LCROSS mission deliberately crashed a rocket stage into Cabeus Crater near the South Pole. The debris cloud kicked up by the impact was analyzed and water was confirmed. Here's a detail worth pausing on. Apollo 12 brought back a piece of the Surveyor 3 probe, which had been sitting on the moon for 2.5 years. Scientists found Earth bacteria on that component. Today, the Artemis program is moving forward, with plans to build a long-term lunar base, turning the moon into humanity's first stepping stone toward deep space. One day, looking at Earth from the moon might become as ordinary as standing on Earth and looking up at the moon is today.